earthly behavior, earthly behavior, earthly behavior, earthly behavior for MCTV. This is Dr. Wald with Earthly Behavior for MCTV. In this session, we're going to talk about a difficult subject. It's quite catastrophic, and I know some of the media has fed on catastrophe to sell papers or sell airtime. That's not the case here. We're just going to talk about something that's happened to Earth before and it's going to happen again, mainly being hit by asteroids or comets from the sky. Anyone who looks at the surface of the moon can see that there used to be a lot of traffic in the area. The moon is just craters upon craters upon craters. And the Earth, if it didn't have weather to smooth the craters over, would probably look like that as well. Even more so, because of our greater mass, we attract more asteroids and comets. But there's no doubt that the Earth has been hit before. In Tunguska in Siberia in 1908, some kind of an object came down and blew up right near the surface of the Earth. From the energy released, they think this object was in the 100,000 ton category, which is about the weight of a battleship or an aircraft carrier. It was coming in about 33,000 miles an hour. That meant that as it impacted or went into the atmosphere, which couldn't get out of the way fast enough, it induced heat in the central core of the air right in front of it. This heat went way up, as 44,000 degrees centigrade at 28,000 feet. For comparison, the surface of the sun is about 6,000 degrees centigrade. So they think that this object came in. They're not sure whether it was a comet or an asteroid. It came in, and at about 28,000 feet, the gases inside of it forced the rock to fracture, and the whole thing blew up in what they call an airburst. This is what they think it looked like in 1908. It was about the power of a 20 megaton weapon. Previously on this, when they finally got to the area, they found that trees had been blown down for 800 square miles around the area. And when you get near to underneath where the airburst happened, they found it was a forest of telephone poles. In other words, there was just trees standing there, but there was no limbs on them and there was no bark on them. This meant that the blast, that whatever put these things down, came from above. And by the way, it has happened since then in Hiroshima and Nagasaki. So when this was analyzed, they found that such things happen about every 300-400 years. This one happened, like I say, in 1908, so we've got a little breathing room. But you know that 300-year estimate is a statistical average, not a hard number one. So these things happen. It's happened to the Earth before, and it'll probably happen again. What are we talking about hitting us? Well, it's either a comet or an asteroid. If it's a comet, we can say, well, it's made of dust, rock, lots of ice, lots of ice. Comets form tails. When the ice gets close to the sun, the sunlight radiation pressure makes the ice turn into a gas, process which is called sublimation. And the gas trails out on the opposite side of the comet from the sun. So the comet goes around the sun with its tail pointing opposite to the sun the entire way. There is a tail that's left behind it, though, that is more where its path has been, and that's the dust that's released when the ice sublimates and turns into a gas. So the comet gradually comes apart and can't stand too many passes around a hot star like ours before it doesn't have anything to give anymore. The orbits of comets are quite outside the solar system. We think they come from a cloud way around the solar system called the Oort cloud. And it's named after a Danish astronomer named Oort. And it's also, these objects may be thrown between solar systems. They may be slung around a star and go completely outside the solar system, and millions of years later arrive at another solar system and be the comet for them. If it was an asteroid, it's different. It's much heavier. There's much more rocks. There's even metal in it. Some of the asteroids are made of mostly carbon, and they think maybe from life forms. The asteroids don't give tails because they don't have enough ice to sublimate. They mostly come from the asteroid belt. We'll talk about that in a second. And they orbit around with the planets. This is a picture of a comet that was taken just a few months ago from it's the comet Hartley 2, made by an American satellite that passed around it. You can see on the one side of this peanut-shaped thing that's about 60 miles long. One side of it is sublimating. The sunlight pressure is making the ice turn into a gas. The other side is not. We don't know why. And notice there's a smooth side around the waist of the peanut. We don't know why that happened either. The comet orbits can be thrown between the stars. There's repeaters that come around every 60, 70 years, like Comet Halley, or there's ones that come in once and go out again and we never see them again. They're only visible near the sun. So if we're to look out ahead and find these things before they hit the Earth, we'd want to have very good telescopes that can see relatively dark objects. And they're not just ice. Of course, there's other things with them as well. When we look at the asteroids, we know that the asteroids are very different. They're, of course, heavier, as we mentioned, but most of them are in an asteroid belt that's about 20 million miles wide, and it's between the smaller inner planets of the solar system and the larger gas giants on the outside. We don't know where the asteroids came from. We don't know if they're the remnants of a past planet or whether they just formed that way and have been that way all the time. We don't know whether they have been beat up by themselves and are gradually becoming finer and finer dust going around. It's quite a bit like the rings of Saturn, this dust-rock combination. Anyway, some of them get nudged out of their orbits and they fly around in non-circular orbits, and they can look like this when you get up close to them. You can see they have craters in them as well, so they've been hit by other things. And there's many of them that are larger than 60 miles, which is a serious, serious hit. The Tunguska asteroid was about 60 feet in width, we think. So something 60 miles in width is a civilization-ending strike. There's 750,000 objects that are around 3/5 of a mile. As they get smaller, they get less lethal, and they also get harder to find. So we need better and better telescopes, and some of which may not have on Earth or may not have been invented yet, but this kind of threat will remain for a very long time. Here's an example of finding them: is that little streak of light there. That's all you see. You take pictures of the same place, very steady, and when one object moves, they see a little bit of light flicker off of it, and that's what they calculate the orbit from. It's a very difficult prospect, and finding these asteroids, these dark circling objects, we need better telescopes and much more search time than we have already. That this has happened before and that it's a serious business is there's no doubt about it. If you remember the dinosaurs, some of you are a little older than others, if you remember the dinosaurs, you know that they ruled the earth for about 120 million years. They were the big dog in the whole place, and they didn't have any problem running the planet. It was no problem until a meteorite came on. You know that the dinosaurs didn't have any problem running the planet for 100 million years or so until something came out of the sky and put everyone out of business. This happened about 65 million years ago. Basically, a huge meteorite came down. It was probably in the 1 or 2 mile size category. And it hit right near the Yucatan Peninsula there on the map of Mexico. It was a long search before they found that crater, and it times out to be the right time. Now, this meteorite, when it hit, if that's what it was, did several things at once. One of the things was it made a planetary veil. It blew up maybe a cubic mile of rocks, pulverized it all, sent it up into the stratosphere, a tremendous explosion. You can't almost get any bigger than this. And all that dust moved into the jet stream and the upper atmosphere and circled around the planet, as it has for other events, such as volcanic explosions, Mount St. Helens, Krakatoa in the 1880s. So a planetary veil is a real thing. It really can happen. And it drops the temperature of the planet several degrees, depending on how extensive it is. We don't know how long this veil lasted. It may have lasted for decades. It may have lasted just a few years. And we also don't know how dark it was underneath the veil. But we know it was enough to make a lot of animals go extinct if they were still around after the blast and the tidal wave. We know that we don't know how long this veil lasted. We know that it was dark underneath it, but we don't know whether it lasted for decades or for a month or for a week. But if it lasted for longer than a growing season, we know that the darkness underneath the veil would undercut the photosynthesis of many plants. That meant that the critters who ate those plants would be out of luck. That may have happened to the dinosaurs too. Many of them were herbivores or plant-eating creatures. But in any case, there's no dinosaurs left. Also, there was a huge wave made with this thing. We have some recent experience with the tsunami at Japan. Well, this wave from a blast like this would go completely around the planet more than once. That's happened before as well. When Krakatoa blew up in the 1880s, the wave it generated went completely around the Earth and met itself on the other side. Is there a chance of another thing like this happening? Well, yes, there is. There's lots of asteroids and comets moving around. Is it going to happen soon? Well, probably not. We don't know for sure because we don't have the telescopes or telescope time to spot every moving object, these are all dark, moving around in the solar system. So we'll keep our eyes out, but we need a much better search and detection strategy than we have now. This is what it would look like, of course, as it came in. Since we are a water planet, it would probably hit the water somewhere. That meant that there would be a huge, huge tsunami go around. Most coastal areas would that would be the end of their time. Survivors would be on the other side of mountains. An ocean strike, of course, being the most probable, that means that when this creature, this asteroid came in, besides heating all the air in front of it, like the one at Tunguska, would also hit the water, and it would heat the water in front of it. Now, water heated into steam expands 1,800 times its volume, so this huge steam blast would come out even separate from the blast of the object itself. What kind of warning would we get out of this? Well, if it was an object around a quarter mile or a half mile in diameter, we'd probably get a few weeks warning. We don't have enough searching telescopes yet to give us more warning than that. Well, it's natural when we're thinking about being hit by large objects is to think about what's the probability, where's the threats, how do we get away from this? One of the problems is to find the threat. So NASA has search programs, and also there's an amateur network of many people who study the sky, and they look for small little objects moving along, and they report them to a central system. NASA needs more money to look for more objects, and really they need satellite telescopes in orbit to really find these small dark objects that can cause us such damage. But even if you had this, what's the prediction time? Well, it seems like if you have a large kind of shiny object, you can find it and predict where it will go about a year in advance. But as the objects get smaller and darker, remember a 30-foot or a 40-foot object is a 10 megaton bomb as far as hitting the Earth goes. The prediction time also gets smaller. We have less and less time to see the small dark objects coming in. In fact, in a 30-foot object, you would have a time of about a week. Then, even with the week warning, we wouldn't know exactly where it would hit on Earth or whether it would just graze along the top of the atmosphere and go back. You say we did know where it was a year in advance. What will we do about it? Well, one of the ideas is we could reprogram nuclear weapons and go out there and blow it up. Well, that's not very feasible. The nuclear ballistic missile program is designed to just hit parts of Earth. It's not designed to go out of Earth's orbit, say, towards the moon or something like that. It doesn't have the rocket power. We had rockets that went to the moon, but we don't have them anymore. So we'd have to arrange to have a rocket that would actually go to an asteroid, a big one. Also, if we blew it up with a nuclear weapon, that would just mean pieces were flying everywhere, and a lot of those pieces would continue on and strike the Earth. So we don't want to do that either. Another thought that has come is we could nudge the asteroid off to one side. We would build a big rocket, squirt it off to the asteroid, and it would land on the surface of the asteroid and start throwing rocks off to one side with a mass driver, perhaps driven by nuclear power or solar power or something. This ejecting mass on one side of the asteroid would gradually nudge it further and further over to the side. Some people said, well, why don't we just build a rocket and put it right on the asteroid? And that's another thought, too. A third idea that has shown up is people would say, let's build a solar sail and attach it to the asteroid and have the solar sail pull on it for years at a time with a small amount of nudge, but it would work if we had enough warning. Well, so far we don't have the telescope time and the quality of telescopes to give us much prediction time. So those different scenarios of what to do about it are in the science fantasy level. What's the chances of this object like this hitting us? Or how many of them are there? Well, the Earth going around in its orbit is kind of like driving on a freeway at 66,000 miles an hour. And if you could see all the meteorites and cometary bodies and everything that's floating around, there'd be a swarm of millions of randomly circling little dots. They were like pedestrians walking randomly across the freeway. By the way, you're in a vehicle that's moving 66,000, but you can't steer it, and you can't slow it down or speed it up. So it's just a matter of who hits what when. If the first thing you'd see if we hit one of these objects would be a flash of light from the stratosphere. The object coming in, we'd only have a few seconds warning usually, and the object coming in would heat up the atmosphere and cause a flash of light to appear all over the Earth. Then the blast wave would show up in the near area. That would mean that cities that were within 700 miles or so of the crater would be obliterated. There'd be a tremendous planetary veil put up. And you'd also have a shock wave move through the surface of the Earth, which would trigger volcanoes and earthquakes as it passed through. This would be much larger than even the Japanese earthquake. The first you'd notice it would be a flash of light, and then you'd feel a sense of heat. And if you were anywhere near the object, that would be the last thing you would sense. If you were to be at a distance from it, like 1,000 miles, a few thousand miles, you'd probably see a wave approaching you of some sort, an atmospheric blast wave, a shock wave, if it was water, a water wave, steam wave, and that would probably be the last thing you'd notice. This can put everybody out of business. This is one of the chances we take in having a planetary system going around. And we're a life form on it, but we're as vulnerable as the next one. The dinosaurs could live through it, which they didn't. Maybe we could live through it. There would be some survivors, probably on the other side of the planet from the strike. So I'm afraid I've given you some cause for worry, as if you don't have enough worries as it is. But I do want you to know the scientific facts of these things. So to wrap up this question, there are a lot of things that can hit the Earth. We don't know where all of them are. The Earth has been hit before and will be hit again. NASA has other search programs, and other sciences have search programs that are trying to find all these things, but it seems like we don't have the political will to look for them. There's other problems we have on Earth that we'd much rather spend our money on. This may be a crisis management problem. As far as defense, we don't have a means of defending ourselves either, and so we'll just have to sit there and take it. That's Dr. Walt with Earthly Behavior for MCTV. Earthly behavior, earthly behavior, earthly behavior. This is Dr. Walt, Earthly Behavior for MCTV.